Geometry, Standard 8. We're going to work this whole standard with the Pythagorean theorem, being able to apply it in different situations. And the learning target we're going to look at first, learning target 1, is that you can use this Pythagorean theorem that you discovered yesterday in your activity to determine if a given triangle is a right triangle. So the Pythagorean theorem only works on right triangles. So if the Pythagorean theorem is not true or does not work, then the triangle that you're looking at can't be right. It could be isosceles, it could be scalene, it could be acute, obtuse, but it is not a right triangle. So just a reminder, I know this is an activity we went over yesterday, but a quick reminder of the Pythagorean theorem. And some people state it as c squared equals a squared plus b squared. I've also seen it as a squared plus b squared equals c squared. And just to remind you, a and b, so this a and this b, which are the two sides that make up the 90-degree angle, are your legs, and then c is your hypotenuse. So yesterday you learned that if you take the area of the square of a and the area of the square of b, so a squared plus b squared, and that will equal the area of c squared. And so that's where this formula comes up. C squared, so this value right here, the area of this red square, is equal to the area of your b squared, because your side length is b, so b squared plus c squared. Or you can write it as a squared plus b squared equals c squared. We'll get to this part in LT2 and LT3, but for right now we're just going to use the Pythagorean theorem as a squared plus b squared equals c squared, or c squared equals a squared plus b squared. So the whole idea of this learning target is, if you look at the lengths that are given, could they make right triangles? So you're going to apply the Pythagorean theorem, because that's what the learning target says. If it works in the Pythagorean theorem, then you have a right triangle. So if we look at our given lengths, we have 9, 41, and 40. So remembering from our vocab, 9 and 40 are the shortest lengths. So I'm just going to do a little diagram here. I'll make a right triangle look like that. 9 and 40 are going to be your leg lengths. That means 41 is your hypotenuse, because hypotenuse has the longest side. So we have 9, 40, and 41. And if we look at the diagram, and this is, by the way, not drawn to scale, so don't get too excited. And they're probably not going to be perfect squares. So if we find the area of this square, which has a side length of 9, the area of this square, which has a side length of 40, it should equal the area of our hypotenuse square of 41 squared. So I'm going to write down the Pythagorean theorem so we can plug it in algebraically as we go. So if we take 9 squared, that equals 81. So 9 squared plus, which was 81. We'll just keep a record over here algebraically. We have 40 is your side length. So the area of this square would be 40 times 40, or 40 squared, which is 1600. So we have 40 squared, which is 1600, equals, and then 41 is your length. And so 41 times 41, since there's a square, that means that all the side lengths are the same. So 41 squared equals 1,681. And I do that with my calculator really quick. So this would be 41 squared. And that 41 squared again equals 1,681. So now I'm just going to do the algebraic math here. I'm going to take 81 and I'm going to add that to 1600, which is 1681. And that does equal what c squared equaled, which was 1681. So I can guarantee or say, yes, these lengths would make a right triangle. And again, because we did the Pythagorean theorem, we took the two legs, we found the area of the squares, and then look at the hypotenuse area. And remember, if these two areas add up to equal your hypotenuse area of their square, then that makes a right triangle, because the Pythagorean theorem only works on right triangles. And we're going to look at this next one. We're going to change this to 27. So notice it's a 27, 25, and 7. So I like a diagram off to the side just so I can visually see it, and then I'll keep the algebra over here to my right. So I have a side length of 27, 25, 20, or 7 again. 27 is my longest, so that has to be my hypotenuse. And mathematically, don't let it bug you. It does not matter what leg length is 7, which leg length is 25. It's just however you want to draw it. I'm going to draw my non-looking squares. Again, not drawn to scale, so don't get too excited about that. So I'm going to find the area of this square by taking 7 squared, because the side length is 7, and 7 times 7 is 49. I'm going to find the area of this square. So one length is 25. That means this length is 25. So 25 squared, or 25 times 25 is 625. And then I'm going to take 27, and I'm going to square that because 27 times this side of 27 equals 729. So I'm just going to record what I have so far, because once you get used to this, you don't always have to draw a diagram if you don't want to, or a picture. It's totally up to you. So 7 was one of my legs. I squared it. 25 was my other leg, and I squared it. And so that leaves me with 27 as my hypotenuse side, and I squared it. Again, if you put 25 squared plus 7 squared, it doesn't really matter mathematically which way you add those two. 7 squared was 49. 25 squared was 625. And 27 squared is 729. I'm going to add up the two smaller squares. Find the sum of these two. So when I add that up, that's 674, and that's supposed to equal the hypotenuse square, which was 729, and mathematically 674 does not. So I'm going to put the does not equal symbol 729. So my answer would be no, these lengths would not make a right triangle. Okay, our last example. So we have given lengths of 56, 11, and 57. So I'll make my diagram over here. Start with my Pythagorean theorem, which is a squared plus b squared equals c squared. And if you rather do c squared equals b squared plus a squared, that's fine, as long as you're adding up the a and b and you're squaring them and then equaling it to c squared. So I look at my lengths. My largest length is 57, so I know that has to be off my hypotenuse. My two legs, one is 56 and one is 11. I'm going to draw my squares, again, not scaled. I'm going to go find the area of those squares. So on this first one here, I have 57 as a side length. So that means this side length is also 57. So 57 squared equals, again, take your calculator and check this, 3,249. I'm going to take 11, so that'll be 11 times 11. I'm going to square that, which would be 121. And then 56, so one length side is 56, that means the other side is 56. So 56 times 56, or shortcut 56 squared, is 3,136. I'm going to record all my information. So my A could be 56 squared. My B length, so this is A, this is B, this is C, is 11 squared. C is 57 squared. So I already did the math here. So 56 squared was 3,136. 11 squared is 121. And 57 squared is 3,249. Again, these two areas of the two small squares off the legs should add up, and we get 3,257, and that should equal my hypotenuse square. But if we look at this mathematically, they do not equal. So I'm going to put a does not equal symbol. So I'd write no, these lengths would not make a right triangle. Because if they don't satisfy the Pythagorean theorem, then they do not make a right triangle. I've got the word right here.